Is 433 in the pattern? Now, before you answer those questions, did anyone think about it at home at all? Do it at home, do it at home. There's how to go, practicing, yeah. Before we go into that, let's just quickly recap what we're doing. Alright, so we were saying if Tn is 5n plus 2, we can use that to figure out the terms in the sequence, can't we? So when n is 1, I'm asking for the first term. You with me, Holden? Yeah? What?
Just trying to grab.
Okay, do it quick then because we've started. If I'm asking for n is 1, I'm asking for the first term. What is the first term of this sequence? Des?
3.
How did you work that out?
5.
Okay, so 5 multiplied by 1 is 5. So some of you might start to go, oh, well, if I multiply by 1, it's always going to be that number. So I just do this number and then this. 5 subtract 2 is 3. Tells me the first term. Oh, that's nice and quick. The second term, there's 2 ways to do it, isn't there, Tristan?
Yeah.
Go for it. Tell me the 2 ways.
Well, on the second term, it's 5 minus 3 times 2. You could do it like that.
What?
Oh, sorry, no. This is a different term. Oh, I'm looking at a different thing because in my book I did 5 minus 3.
Okay. Ryan, what would you do? What are the 2 ways?
I just looked it up and it was 80.
But how did you do it?
That minus 2.
Are you answering a different question, or are you telling me what the second term is? Okay. G?
So we could do 2 ways.
5 times 2. Yeah, so 5 multiplied by 2, 2 lots of 5, is 10. Then you subtract the 2 and you get 8. And the second way is, how do I know it's add 5 every time? Because we have n lots of 5, so we know it's adding 5 every time. If it's n lots of 5, it's 1 lot of 5, 2 lots of 5, 3 lots of 5. So that's the adding on bit, and the core bit is the minusing 2. Alright, that happens every time. So we could just add 2. So the third term, I could do 5 times 3 minus 2, or I could just add 5, okay, which would give me 13. And the fourth term would be add 5 to give me 18. And the fifth term was add 5 to give me
23.
and the keen-eyed amongst you will go, oh, I see the pattern. It's 3, then 8, then 3, then 8, then 3, then 8. Okay? I then said to you, well, the 100th term is when n is 100. That's the 100th number in the list. Are you with me, Zavi? Because your book isn't open and you're not writing anything down. Your notes are not going to be very good if you're not doing any writing. So same as usual, yeah. I know we're repeating, but at some point we're going to write something that's added. And you might want to put that in, yeah? Yes, King?
433 isn't in the pattern.
I'm not there yet.
Oh, okay.
Alright? So 100, this one, because I'm not going from 5 straight to 100, I can't do the add 5 bit. Alright? I have to do the 5 more. So 100 lots of 5 is 500. Then I subtract 2 and I get. Alright, so then I asked you a question which was, is 433 in this pattern? And I said to you, I don't want your reason to be because it ends in a 3, even if that's correct. Here, what do you think? Is it in the pattern and how? How do I know? You don't know why. Okay. Tristan?
It is in the pattern, and it's the 87th term, because yes, it is. Because 87 times 5 is
433.
433, right?
Yeah, but you go.
Oh yeah, but then you have to take away 2, so it's not.
Yes, it
No.
is. No,
I was just trying to see what times 5 equaled
Yeah.
435, and I just realized that it's 87 times 5. And
You just realised.
And it says 4.
Just came to me. Just, you know.
It is
I just like that.
So you subtract 3, that makes 433.
Right, so it's fine, right? You guys have used a perfectly reasonable method, which is a trial and error method. Yeah? You can estimate to start with and go, well, 433 is quite a big number, right? I know I've done the 100th term, which is 498, so I know it's going to be less than 100, yeah? Because that's going to get bigger. It's going to be less, but it's going to be somewhere up there, right? So you could start with, I'm just going to try 90. 5 lots of 90, or 90 lots of 5, and see what that gives me, all right? And then you can try and error it to get to the right number. But that's a bit kind of hit and miss, isn't it? What if that takes you 10 minutes in an exam to do that? It's not what we call efficient. You might get the right answer, but unfortunately in our assessment system, time is a factor. So people get higher grades if they can do the correct answer quicker. So if it takes you a long time to get to the right answer, you still get the right, that's great. But you then run out of time to do some harder questions. So that's part of it. It's not really real life, is it? You know, you get longer. Like if you need 5 hours to do something, you just have homework to do, right? But unfortunately, our system, I think in one of the Scandinavian countries, they have as much time as they like. I don't know that, but for some of you, you get to 3 hours and I'm just going home. G.
You get 435, and I got 435 because 435 plus 2 is 435. And we can ignore the plus 2.
Okay, so before you get there, right, he's given me a good... Right, so I remember saying yesterday, what we can do is what we're asking is, does 5n subtract 2 ever equal 433?
Yes.
All right? So that's what we're trying to do. So now, this is the next phase. This is what we have to be able to do. This is where the algebra tiles come in. All right? It's going to be harder for this big number, but I'm going to go through this, and then we're going to use the algebra tiles for solving other equations if you need them. All right? So just, Mackay, right? Just so you're aware, this is now the point, the new stuff. This is the important bit. So those of you that are a bit switched off, switch back on. Right, G.
So we got 433. It's definitely part of the pattern. You can ignore the minus 2 for now.
Oh, I don't like that method. Explain. Just before you, G, before you go any further, I will let you carry on. But what I want you to be aware of is that there are people in the room that are relying on this explanation. So imagine your criterion C. It's communicating clear, coherently, concisely, so that other people can understand. I might be able to figure out what you're saying. Just take a moment to think about what you're saying. So if you just say, oh, well, let's just ignore the minus 2 for a bit, be clear why. Okay, you ready?
So
Go.
so we'll first get to the original number before the pattern is due. So it'll be 435.
Why would it be?
Because 433 doesn't lead to negative 2. So 87, 5 times 87 plus 56 was 435. We equal 435. And then the minus 2 brings it back to 435.
I get it. I think we just need to add a little bit in to explain what he's trying to say. All right? I'm doing this with my M3s at the moment, guys. So this is the thought process that G's trying to explain. Keen, what do you want to say?
Well, maybe if it helps or something, I don't know. The 5n, 5, oh, never mind.
Right, I think what they're both trying to say is this. Are you all with me now? Big hand up. Again now. Right. The idea is, this thing here, do you remember we did like 5 multiplied by 2 is 10? Then I subtract the 2. Yeah? What G's saying is, well, let's figure out what the 5n bit has to be before we subtract the 2. Yeah? So what I'm going to do is this. I'm going to box the 5n for now. I'm going to forget it says 5n. Right? Got that? And then I'm going to ask you, what subtract 2 makes 433? Okay. 435. I know that 435 subtract 2 gives me 433. Now, there is a method for saying that. Do we know what that method is? Georgie, are you with me? Yeah? Do you know how to show that 435 subtract 2 is 433? What would you do? Well, how could I know that it's 435? If I'm only at that stage, the box subtract 2. Any ideas mathematically how we could?
Go up by 2 and then
Exactly that, right? Got that? Just add the 2 back on, which is what G was trying to say. If I just add this 2 back on, yeah, I haven't got the subtract 2 anymore. But the 433 must then be 435. Now here's the next step, which is, well then, what was in the box? 5n. So I can now say that, well, 5n has to equal 435. Yeah? Write this down, Zoe? Yeah, nice and neatly, got it done? Sure? Nice structure down here? Good? What about you, Georgie? Got it written? Can you see it all? Ryan?
Maybe everywhere, I might not think it's right, but if you know that you're subtracting 2 from whatever number is more,
Yeah.
because you know it's 435, right? But you don't know what the multiply is, you can just do 435 divided by 5.
So that's the next step, isn't it? Yeah. So 4 multiplied by something, no, sorry, 5 multiplied, n lots of 5 makes 435. So, like you're saying, Ryan said very correctly, well, if it's n lots of 5, we've got to divide it into 5s, yeah? So n will be 435 divided into 5. So how many 5s? Because if you think about how we started, it's like 1 5, 2 5s, 3. So I need to know how many 5s can I take out of 435. And if you do that on your calculator, you do it. Hazel, what's the answer to it on your calculator? Yeah? Everyone should have your calculator out.
I can do it.
Okay?
So 435 divided by 5 is 87.
Okay. So n is 87. Alright, so what does that mean? That 433 is the 87th number term in the list. Right, now I've got a question for you. Well, I've got another one, I've got another example. Have you written that down, Zoe? No? You're going to do it, good. Stay with me, stay focused and write these things down. Alright, so there is a question in criterion D. Alright, criterion D. Does anyone know what criterion D in maths is?
Pattern.
It's not patterns, that's B. B is patterns. D is.
No, isn't C is the one that you don't know.
No, C is communication. Makes sense.
D is the one that. D is what is use the stuff running to figure out new things.
No, we don't really have a criterion for that.
That's
actually.
criterion.
A is just skills and knowledge, so just basic, do you know how to do stuff? B is if I give you some maths, can you figure out patterns and generalise it? C is can you communicate and write things clearly and concisely? D is it's not critical thinking in maths, no. But that's one of our ATLs though. Yeah?
Understand?
It's not just understanding, that's another ATL. It's actually applying maths in
Real
real life situations. Now, one of the strands is, does your answer make sense in the context of the situation? Alright, part of it. So in your upcoming assessment, it's going to be a BCD assessment. Alright? the next says, does that make sense? So, I'm going to give you another question. All right, same lines. I'm going to ask you to figure something out. Does it make sense? Right. So, bear with me. So, if I say, I'm going to give you a new rule. You all right, Reese? You comfortable now? Are you able to use your arms and hands just like that? If I say to you, Tn is 2n minus 1, okay? I'm going to say, just a nice simple one, is 17 in the pattern? Okay? And then is 32 in the pattern? I don't want your hands up just yet. So what I want you to do is I want you to work out for both of them. So you know the process, right? The way to say it is you need to figure out which term it is, yeah? So to answer this question, is 17 in the pattern, the way to do it is to figure out which number it is, yeah? So what we're going to write is we're going to write, for this cut, is does 2n subtract 1 equal 17. In this case, does 2n minus 1 equal 32. So I'm going to ask you to find what n is. Okay, good. I don't want an answer. You can ask a question, but I want all your solution written. I want to see it really nice. You see how I wrote a nice structured solution? I was clear. I want to see the same for you for both of those. And then I want you to say at the end, I want you to think about this criterion D aspect of, does that make sense? Yeah. Got it? Put your hand up if you need any help at this stage. So, we are saying, does, oh, that's bad, isn't it? Does 2n minus 1 equal 17? So, I'm going to do 2n minus 1 equals 17. Alright, so the process is I need to figure out what the 2n needs to be before I subtract 1. So what does the 2n need to be? So I know you guys know what you're doing, so I'm just not going to ask you for a while. Okay? Ask me a question. Okay. Yeah, there could be a decimal. Could be a decimal, but that's the doesn't make sense bit. Right? So, Hazel, if 2n's minus 1 equals 17, what must the 2n's have been before you subtract 1? 18. Got that, Kira? Something subtract 1 makes 17, so the something must have been 18, yeah? 18 subtract 1 makes 17. So I did that by adding the 1 back on. Okay? So I've got 2n's make 18. So, Keith,
Can I give me the answer for what
give me this one. Therefore, n must be
4.
What? I know. What? It's supposed to be 9.
supposed to be 9, isn't it? If 2n's make 18, we divide it by 2.
You just add it up. That's how I got it.
You don't add it up.
Add what?
Oh.
Alright, so, is 17 in the pattern?
Yes.
Not just yet, not just yet. So, Zoe, you now have a line on here. So you can write like this, and then I can write n equals 9. So we can say, yes, it is the 9th term. Yeah? All right. Next question. How do you get, Georgie, did you get that? Make sense? Yeah? Emma?
Oh,
Yeah? You're going to stand me and say, the next question is, does 2n minus 1 equal 32? Des, what do you think? What do we do?
Oh, what do we do? Okay.
box,
Okay?
and then we've got to figure out what the box is.
Yeah.
So, you know, because it's subtract one, if you add the one on,
Add the 1 back on.
you know how much, like, what number you subtracted 1 from to get the 32.
Yeah.
So then you've got to find what the 2 is.
Yeah.
So if
So 2n must be equal to
33.
33. Okay.
So then you've got to say n would have to be 33 divided by
Good. So 33 divided by 2, and I get n equals.
16.5.
Okay. So over here I can write n equals 16.5. So
I was sort of thinking there, because it is
It's not
because it's not
Because the pattern doesn't. The pattern will be going up in even numbers, and
Yeah.
it has a
It's
point
not
5 just stuck in
It's
the middle
not a
of it.
pattern anymore.
okay. Good. You're getting it, aren't you? The fact is, right?
Finally,
I get it.
What we've got to do, what you've basically all done, really good. Hold on a minute. You got this, didn't you? Yeah.
No.
Good. You got it. Why is it a no, Holden?
Well, because
What's that? How is it?
because you are. Oh, you're not using 16, right?
That's it, isn't it? A term would be n. It would be 16, or n would be 17, or n would be.
Because you can't have
18.
a half.
Can't have half the term. You're right. Yeah, exactly that.
Then it's not a linear pattern.
It is a linear pattern,
Yeah, because if you add
but the thing for the criterion D, what we have to say is, does my answer make sense? And this would be no, right? It's not in the pattern, okay? Because n needs to be a whole number. Does anyone remember what a whole number is called? Emma? Dean?
A square number?
I haven't.
Okay, come back to you.
decimal points.
Can't. Do we know what it's called? You right? A whole number has no decimal places. It's called not an irrational number. That's like quasi-irrational. It's called an
Integer.
integer. That's a name for a whole number. So this is an important one, especially for your assessment coming up next. All right. With these sequences, with these patterns, if we find n and it's not a whole number, it's got a decimal, that doesn't make sense. Now, doesn't mean we've done anything wrong, totally. It just for n does not make any sense. That's your criterion D. Alright? Does that make sense? We. Yeah.
There's all kinds of easy ways that make you express, but we all know that 2 doesn't go into 33.
Okay, so that is another, for those of you that remember your divisibility rules, stop. Right? If I double a number, I always get an even number, and then if I subtract 1 from an even number, I always get an odd number. So it doesn't matter what n is, this will always result in an odd number. Therefore, asking will it ever be an even number, I could have already gone no. That would have been another reason. Okay? Alright. Is there anyone thinks they're struggling with this bit? No? Right, so I'm going to show you now, for those of you that might need it. We'll all do it, right? And then if you decide you don't need it, you can just stop using it, right? I'm going to show you how you can solve these things using the algebra tiles, all right? Click on this first one. You'll notice that the big squares these things I didn't want to use, right? So if you're on the computer, we only need the first option. Now you will notice, look, over here on the computer, we can drag over a bar. What does the bar say on it? An X. So this bar, you with me, Zoe? This bar represents an X. That's the number I don't know. In what we're doing, it represents actually an N. Because it doesn't matter what letter it is. Now, you'll also see, excuse me, on the computer, I've got a plus and minus button down here. If I click the plus and minus, I get, what does it say? Negative X, so subtract X. So one colour is positive X, the other colour is negative X. Now, what I can do, I believe, is I can change the colours of these, but we're not going to worry about it. I don't want to do that. So on your bars that you guys have got, one side is red, the other side is green. One side means yes. The other side means yes. Right, good. That's one thing sorted. These little squares on the computer, we have, what does it say? 1 and? What do you think these little squares are?
1 and negative
1 and negative 1. Now what you need to do, guys, those of you with the blocks, you need to decide which colour is the positive and which one's the negative. So I suggest, because it's red, red and green, white, maybe we keep the reds as the positives. Alright? So let me show you how we can use these algebra tiles, alright, to solve a problem like we've been working on. So, sorry, I'm not going to be able to put it on the screen like in writing, but on your book, alright, let's solve this one. Does 6, okay, does 6 appear in 2n plus 4? It's a nice simple one. Okay? Does 6 appear in 2n plus 4? So we're basically going to do what we call solve 2n plus 4 equals 6. Alright? And then remember down the side we're going to say, well, n equals something. Alright? If it's a whole number, we'll say yes. If it's a decimal, we say no. Right? So those of you that might struggle with it like this, let's show you how to do it with the algebra tiles. So I want everyone to do it with the algebra tiles. I'll run through it. Thanks if you want to offer, but just do it quickly. So what we need to do is set up our algebra tiles. So for me, I can click on here, and I know some of you have done it. I can draw a line down the middle, and that can be my equals line. All right? Click that, get rid of it. And what I'm going to do, so you can click on these and you can delete them, trash them. Okay, you can copy and paste. Now, I need to set up the 2n plus 4 bit on one side and the 6 on the other. So I'm going to do this. I can have 1n, or it's an x, and then I'm going to have a second n. 2 n's.
Oh my god!
Yeah? Make sense? So on your things, can we do it all on the algebra tiles? If you're doing the blocks, just put 2 of them down. All right? How do you think I represent the plus 4? G? Well, I'm on algebra tiles. I don't need spaces, really. I can just do... Just get 4 of them. Now, what I'm going to do is I'm actually going to lay them out next to each other like this. Because there's something good on the computer, which will probably make some of you want to use it. All right? So I've got my two n's and 4. So that's what a plus means, yeah? Add them together, put them together. So those of you that have got the blocks, you should have this lined up in front of you now. All right? Like I said, let's do it together now. We've got 5 more minutes. If you then choose to not use it in the future, that's absolutely fine. But for now, let's do it. All right. On the other side of my line, this is equal to 6. All right? So I'm going to put, and on my computer I can put 1. I can actually change the number that I put out if I want. So I can click on 5, then drag, and I get 5 of them. All right? The other way is to click a paste button. All right? But those on the computer, you'll get to play around with that. So I've got 2 n's plus 4 is equal to 6. All right. So have you got that set up with your bars? Have you got... It's all positives. There's no negatives in this at all. I've got 2 bars and 4 units on one side. Is equal to, what does equal to mean? Is equivalent to, good. Same means the same thing, but they look a bit different, right? So on the other side, I've got 6 units. So these two are the curse of the nail. King, curse of the nail. Logan's not even in here today. I'm going to take it out. Jackson. No? You respect. Right, let me show you what we do then. So do you remember the process was to work out what the 2 x's had to be? And we did that before we added the 4 on. So this is what we do. I want to get rid of the 4 on the left-hand side. So I'm going to do this. I'm going to have a negative x because I've got positive x. I'm going to have 4 of them. All right? So can you take another 4 little counters, turn them the other way round, so you've got different colours, and that suggests the negatives. But what we have to do then is, on my computer, I can drag and paste. I also need them on the other side.
This is why I prefer to use
Yeah, that's right. That's why I've got some other sets. We can, like, if things get, for those people that want to use it. Right. Have you got it? They do look a bit sweet. So I see Tristan's looks good. Oh, good. All right. Now you'll notice I only said these, not the bars. All right. Now there is a reason for this. If I add a 1 and a negative 1 together, what do I get?
-1.
No.
0.
0. It gets rid of it, doesn't it? So do you remember when we were doing this, we said 2n plus 4 equals 6, and we said what we need to do is subtract the 4. Or add a negative 4. Subtract 4, add a negative. So on my computer, those that have got it on the computer are going to love this. What then happens is you do this. If you've lined them up, anything positive and negative, we overlap them. And look what happens on my screen, guys. Okay. Let me just show you that again. Look. So what I've done is I've clicked and dragged over them all. All right. So they're all highlighted. I then click and hold on the computer and I drag them up. I can do them one at a time. But like I said, a positive 1 and a negative 1 make
0.
So what that means is 2 n's must equal 2. Right, so that's what we've got on the board as well with our numbers. So we end up with 2 n's equals... Now, here's the next phase. With your algebra tiles that you've got, the 4 that were different colours, if you push them up into the red ones, right, that gets rid of Lenny, yeah? So the number of white ones that you have will eliminate the number of red ones, so you can take them away. Okay? Got that? Have you all done that? Oh, you've got fancy colour ones.
Yeah, that's those are the ones that I like.
They're weird ones. They were right. They work alright. Right. Are we good with that? What are you doing, George? Right. Now, guys, here's the bit. Do you remember what I said about needing time, guys? I'll take it back on a Friday if I can't get through it. All right. Now we've got to do the division. So, what is another way of saying division? Fraction is a division, and a division is when you split things up. So what I'm going to do, look, here's my 2 ends on one side, and here's my 2 units on the other. I'm now going to split my 2 ends and equally share these sides. So I can now say that 1 n has to equal 1.
Oh my god. This is the
Okay, right, can you all be silent? I will give you a detention if you can't be. And that'll give you... Alright. We stop pausing. Stop pausing, start pausing. Alright, I know the bell is gone.